myself Hena Shah, Assistant Professor at LG Institute of Engineering and Technology. So today we are going to discuss a topic of Laplace transforms. So the topic is solution of ordinary differential equations. So if y of t is equals to y of s, then Laplace of y dash of t. This is Laplace of derivatives only. You have to just use the same formula. That is sy of s minus y of 0. Similarly, Laplace of y double dash of t, that will be s square y of s minus sy of 0 minus y dash 0. In general, we have to write s raised to n y of s. Now start decreasing the powers of s. So lastly we will have 1. So decrease the power of s and increase the power of small y. So here what will come? Y of 0 and so on. Y raised to n minus 1, 0, right? So this is our formula to find the Laplace of nth derivative of y of t. So let us start solving. Now let's go to our next example. We have to solve the following differential equations using Laplace transform. So we are given two ordinary differential equations, right? And x of 0 is equals to 0, y of 0 is equals to 2. So let us begin with the first equation. So I can write this as x dash plus y is equals to sin t, right? Now let us apply Laplace on both the sides. So Laplace of x dash plus Laplace of y is equals to Laplace of sin t. Done? Now let us apply the formula. So this can be written as x of s minus x of 0 plus this is y of s, Laplace of y, and Laplace of sin t, that will be 1 upon s square plus 1. Now our x of 0 is 0, so this is gone. So finally we have our equation as x of s plus y of s is equal to 1 upon s square plus 1. Let us name this as our equation 1. Okay. Now let us find our solution of second equation. That is y dash plus x is equals to cos t. Apply Laplace on both the sides. So Laplace of y dash plus Laplace of x is equals to Laplace of cos t. So Laplace of y dash will be what? Sy of s minus y of 0. This will be x of s is equals to Laplace of cos t is s upon s square plus 1. Now let us put the value of y of 0, which is what? 2. So finally sy of s plus x of s is equals to s upon s square plus 1 plus 2, right? So this is our equation 2. Now let us solve this using our elimination method. Now let us multiply our first equation by s. So on multiplying this equation by s, we will get s square x of s plus sy of s is equals to s upon s square plus 1. And keep this as it is. So first I will write x of s. So x of s plus sy of s is equals to s upon s square plus 1 plus 2. Now let us subtract these two equations, right? So finally on subtraction, what I will get is this s square minus 1 x of s. This x of s will get out common. These two will get cancelled out. This also will get cancelled out, is equals to minus 2, right? So finally our x of s is what? Minus 2 upon s square minus 1. So our value of x of t, that is Laplace inverse of x of s, right? Laplace inverse of x of s. So find the inverse of this. So it will be minus 2 sin ht, hyperbolic function, because we have s square minus 1. So we have got the answer of x of t. Only one answer is remaining to be found out, that is y of t. Let us use our equation number 1. In this we will put our value of x of s. So our x of s is this, minus 2 upon s square minus 1. So x of s, the equation is this, right? Put this value inside this, so we will have minus 2s upon s square minus 1 plus y of s is equals to 1 upon s square plus 1. So finally then y of s will be 1 upon s square plus 1 plus 2s upon s square minus 1, right? Now just find y of t, that is Laplace inverse of y of s. Just find the inverse of this. So the inverse of 1 upon s square plus 1 will be what? Sin t. Plus 2 will remain as it is. Inverse of s upon s square minus 1 will be cos ht, right? So this is our answer of y of t. So these two are the answers which are required. Okay. I hope you have understood throughout the session. Thank you for watching.